Did you know that cement is one of the most widely used construction materials in the world? From towering skyscrapers to sturdy bridges, cement plays a crucial role in our everyday lives. But have you ever wondered how this essential building material is made? Today, we're going to dive deep into the fascinating world of cement manufacturing and explore the intricate process behind the fundamental building blocks of modern construction. Our journey begins at the source, the raw materials. There are various types of cement, but the most commonly used is Portland cement, which Joseph Aspdin, an English mason, obtained a patent for it in 1824 and named Portland cement because it resembled Portland stone, a type of building stone quarried on the Isle of Portland in Dorset, England. It is typically made up of 60 to 65% limestone, 17 to 25% clay or shale, 3 to 8% silica, 3 to 8% alumina, and 1 to 4% iron oxide. These proportions are carefully controlled to achieve the desired chemical composition for the production of high-quality cement. Since most of the Portland cement consists of limestone and clay, cement factories are established in areas where these raw materials required for cement production are available. These materials are usually found in abundance in areas such as quarries, mines, and open pits. Cement factories are typically located near these sources of raw materials to minimize transportation costs. The process begins with the mining of these raw materials, where limestone and clay are blasted from rock quarries, which are then transported to the plant and undergo various stages. Raw materials once extracted and transported to the cement plant, the manufacturing process begins. At the cement plant, the raw materials are crushed and ground into a fine powder. The powdered limestone, clay, and other raw materials such as shale and sand are combined in precise proportions and blended. This process ensures that the ingredients are thoroughly mixed and homogenized, creating what is known as raw meal. The raw meal, which is a finely ground mixture of raw materials, is then heated to extreme temperatures, reaching around 1450 degrees Celsius in a rotating kiln. The process of heating the raw meal involves several steps. Preheating. Hot exhaust gases from the kiln are used to preheat the powdered raw meal before it enters the kiln. This preheating step helps to reduce the energy consumption in the kiln. Calcination. The raw meal enters the kiln at temperatures of around 1000 degrees Celsius. Fuel is fired directly into the rotary kiln at up to 2000 degrees Celsius to ensure that the raw materials reach temperatures of up to 1450 degrees Celsius. The intense heat causes chemical and physical reactions, leading to the formation of clinker. Clinker production. The raw meal is partially melted in the kiln, and as it moves through the kiln, it is transformed into clinker, which is a nodular material. Cooling and storing. From the kiln, the hot clinker is cooled using large quantities of air. The cooled clinker is then stored for further processing. The heating process in the kiln is essential for the transformation of the raw meal into cement clinker, which is the key intermediate product in cement manufacturing. These clinker are small, marble-sized nodules that consist of calcium silicates, aluminates, and ferrets. These possess the necessary chemical properties to form hardened cement. The clinkers are then finely ground and mixed with gypsum, and often with alternative raw materials to make cement. The grinding process enhances the cement's reactivity, ensuring optimal performance in various applications. Gypsum is added to cement to control its setting. Gypsum slows down the hydration process of cement by reacting with the tricalcium aluminate to prevent the flash setting and reduce the solubility of the aluminate, thus delaying the setting time of cement. This allows for a longer working time for mixing, transporting, and placing the concrete, which is important for its strength, composition, and workability. If gypsum is not added, then cement will set immediately after mixing with water, leaving no time for concrete placing. After each batch of cement is manufactured, Samples are collected from various stages of the production process. Once the samples are collected, skilled quality control technicians perform tests to assess various properties of the cement, including fineness, setting time, compressive strength, and chemical composition. These samples undergo a battery of tests to ensure that the cement meets the stringent quality standards set by regulatory bodies and the company's internal benchmarks. The results of these tests are meticulously documented and analyzed. Any deviations from the established standards are thoroughly investigated, and corrective measures are implemented to maintain the highest level of quality. Once the cement has passed quality control, it is packaged into bags or bulk containers, ready for distribution. Cement manufacturers work closely with construction companies and suppliers to ensure a smooth and timely delivery to construction sites worldwide. And there you have it, the journey of cement, from raw materials to the cornerstone of modern construction. As you marvel at the buildings around you, remember the intricate process that goes into manufacturing this essential material. Thank you for joining us on this exploration of cement manufacturing. Until next time, stay curious and keep building.